All right. Good morning. For this video, this is going to be part 1 and 2. I'm just going over the 610 task where it talks about finding the height of a tree. So here's the diagram. I drew the tree. You don't have to draw the tree. One thing I did add to this, as you can see, is the imaginary line that goes through point A right here. And there's a reason why I did that. There's a couple of terms that we need to look at and see, because we're probably going to see those terms a little bit later down the road. One of them is actually written inside the triangle. As you can see, if we look at the figure and we just basically go off of what information do we know, or what do they give us, they give us the fact that BC is 40 feet, or the shadow of the tree. Well, when we look at it from a triangular perspective, 40 feet is a leg, right? Then it talks about 50 degrees being an angle of elevation. Well, 50 is the angle inside. Angle of elevation. Elevation means up, so that's an angle looking upward. The reason why I drew the imaginary line is that this imaginary line is parallel to the base, and whenever you have two parallel lines cut by a transversal, you have alternate interior angles right here. So this angle right here would be 50 degrees. These two would be the same, and as we have an angle of elevation, we have an angle of depression. What is an angle of depression? The angle of depression is looking downward. That is just a geometric term that they use. So if we read on and we come across a word problem where we actually have to draw a figure and label it, which we will, and it says the angle of depression is 50 degrees, the angle of elevation is also going to be 50 degrees. They are equal in number all the time, but how we name them determines on whether we're looking up or looking down. So just to know that. All right, getting back to the rest of the problem. I don't know the height of the tree. That is what I do not know. I do know the shadow is 40 feet. The shadow is a leg. The angle of elevation is an angle. The tree, looking at it from a triangular standpoint, is a leg. I do not know the other leg of this triangle. The other part of this that I do not know is I do not know the hypotenuse. That's important, because if I'm sitting back and I'm looking at this going, gee, which trigonomic ratio do I use? Because that's what they're telling me I need to do. How am I going to use a trigonomic ratio to solve for the height of the tree if I don't know the hypotenuse? Remember and they're over there, you can't see them. But if you remember SOHCAHTOA, which trig functions can I not use? I cannot use sine and I cannot use cosine because they both involve the hypotenuse. I don't know the hypotenuse. That means I can only use tangent if I can do that. Well, this is where you got to pay attention, because now they're giving us a measure of an angle. So that measure, that 50 degrees, is going to be included in my ratio. So can I? Let's just see. The tangent of 50, and if I can create this ratio, I'm only going to have one unknown. The tangent of 50 degrees is going to be equal to leg opposite, I don't know, my unknown, over leg adjacent, which is 40. There you go. You have one unknown. Remember yesterday when we created, or the other day when we had the worksheet and we created a ratio when we were trying to find an angle, the unknown was in here. Now the unknown's over here. Oh no, what do I do? Well, any number, the tangent of 50 represents a decimal. If you were to put it in your calculator, it would spit out a decimal. It's a decimal over 1. Any number is a fraction. I can write it over 1. How do I solve proportions? Because what I'm saying is this is equal to this. That's what I'm saying. In order to make them equal, I have to pick a number that's going to go here, so when I divide it by 40, it's equal to that. Well, I cross multiply. That's how I solve proportions. So x is equivalent to the tangent of 50 degrees, which again represents a decimal, times 40. The number that would go in here, if you use, and at this point I'm done with all my manipulation. At this point right here, if you plug it into the calculator, it would say 47.6. So the height of the tree is 47.6 feet. All right, so that's how that works. This right here is what you would plug into your calculator. Fine. Calculators. Plug them in. Use them. Flip over on the back, part 2. It says, what's your angle? Well, again, this is just getting us to create angles. It says, name the trig ratios for angle A and angle B. Based on what they give me. Right? Here's angle A, here's angle B, and then C is the right angle. Based on what they give me, the only ratio I can create is, again, remember, so, ka, toa. What do they give me? Well, 40 feet is a leg. Here's a leg. I don't know. Here's a hypotenuse. I do know. So what am I given? From A, I'm given the leg opposite over hypotenuse, which is opposite over hypotenuse. So the sine of A is the only ratio I can use, 40 over 100. I can't use cosine because I don't know the leg. So now I switch over to angle B. All right, well, from angle B, I know 40 is a leg, but is it the leg opposite or leg adjacent? It's the leg adjacent. So the cosine of B, excuse me, not A, B is the only ratio that I can create based on the information they gave me. And 40 over 100. Gee, what do you know? They're both the same. Yes, because the sine of A is the same as the cosine of B, if you remember that. All right? And then 3, it says, how might we commence? Well, if you go through and read the story, okay, I will save you the time of going through and, well, you should go through and pause and read the story. But I'm not going to go through and read the story. You don't want to hear me read a story. Basically what they're saying here is, gee, before I solved for a side length, now it wants me to solve for an angle. Well, if I solve for a side length right over here, I used the regular tangent function. But over here I'm using a regular sine function. So how do I get, if this is my question, my problem in question, which we've already seen this, all right, 40 over 100, if I've seen this problem here, right, how do I get A by itself? I get A by itself by performing an inverse operation. I've already talked to you all about that. How do I get rid of sine to get A by itself? I multiply by sine inverse, or I divide by sine inverse. Either way, all right? It's the same thing, all right? So if I multiply both sides by sine inverse, all right, A ends up being by itself, and what you end up having to put in the calculator is sine inverse of 40 divided by 100, and that would actually tell you your answer. And in the notes down here, it tells you that this is 23.578 degrees, so 23.5 degrees, roughly 23.6, if we round it to the nearest tenth. All right, you don't have to get too technical when we're just learning. All right, but as you design and build things, you get more and more technical. Okay, so it's basically their assumption was the inverse operation. Now, the other thing you're going to work out today is you're going to get a worksheet in class, and it's going to talk about what we've gone over the last couple of days. All right, you're going to have to create the ratios for the first few. That's all you're going to have to do. And in fact, let me go ahead and I'll just cover all that. I think I'll go ahead and cover all that right here in class, because I'm going to hand out that worksheet. I know I disappeared from the camera, but I'm going to come back. Just to make sure we know what's going on. Okay, so for the first 8, you need to, it says create the correct ratio. All you need to do is create it. So problem number 1. Problem number 1 right here. I'll just make some space. I'm going to keep that for later. Here's problem number 1. Here's your triangle, right? You got your angle. Now, it just says create the ratio by choosing which of the 3. So am I going to choose sine, cosine, or tangent? Well, yeah, in the past I've had you mark all the sides. Well, what do they give me? What is 68? Leg or hypotenuse? What is 22? Leg or hypotenuse? They're both legs. If they're both legs, I can't use sine or cosine. So tangent of x is equivalent to leg opposite over adjacent, 68 over 22. Okay, so create it. from the information you're given. You do not need to solve, just create the ratio. I'm done. I move on to question number 2. I move on to 3. I move on to 4. Number 5. Number 5. I'm going to go ahead and erase this because I can do that. So now this is number 5. You are given this triangle. And it says x gives me a degree, gives me 18. Which ratio do I use? Sine, cosine, or tangent? Well, what do I know and what do I want to find? I know an angle and I know a leg. I want to find the hypotenuse. Well, from this angle, 38, is 18 a leg adjacent or a leg opposite? Well, opposite would be over here. Don't know that. Adjacent is here, so this is going to be a cosine of 38 degrees is equivalent to, create your ratio, adjacent, 18, over hypotenuse, x. There you go. X happens to be in the denominator. All I said was create the ratio. That's all you got to do for the first 8. 9, 10, you need to create the ratio and show all work necessary to get the variable by itself. So here we would cross multiply if that's what we needed to do. Same thing for 11 and 12. 13, 14, 15, 16, just create the ratio. So pay attention to the directions. 17, 18, find the missing side. So it kind of goes back and forth. So there's an example of what to do with the worksheet, and I will post the worksheet on your assignment actually, if you need it, if you're not here. That's what you need to do. That's what we're working on in class today. Have a happy St. Patrick's Day.